Hey everyone, we are back with more differentiation techniques. We've looked at power rule, we've looked at trigonometry, we've looked at exponential, and now it's time to look at the cousin of exponential, the natural logarithm, ln x, and just a generic logarithm, well, log ax, for example. And I'll restrict the a again, so a is more than 0, and this time round, there is one more condition that a cannot be 1. We'll kind of find that out in a moment's time, but if you think about it now, there's a reason why a cannot be 1. Nonetheless, dy dx. So the main technique in differentiating logarithm, first you put the function inside the logarithm at the denominator. So I have x at the denominator. The numerator will be me differentiating the function inside. So if I differentiate x, I'll get back 1. So yeah, the derivative of ln x is 1 over x. Similarly to y equals to log ax, it's the same technique. Only difference is it's very similar to a12x that I must involve a ln a, but it's 1 over ln a, and therefore for log ax is 1 over x ln a. Similar to your power rule, your trigonometry, your exponential, I can extend this to y equals to ln x squared. And yeah, it's basically the same thing. Put the original function below, x squared, differentiate x squared to give me back 2x. I will therefore have 2 over x. Then if I move on to log ax squared, so y equals to log ax squared. So dy dx, same thing, 2 over x times your ln a. And as such, we kind of have this formula, alright, this general formula where we have y equals to log a fx. This then gives the derivative, again, general formula, f prime x over fx times 1 over ln a. And this is where we realize that a cannot be 1, because ln 1 equals to 0. 1 over ln 1, well, it's undefined, right? And that's why a cannot be 1. Another way to think about it is that if a equals to 1, that means 1 to the power, let's say, for a certain k has to equals to any x is impossible, as x will only be 1. X can only take 1 and no other value. And as such, log 1, there's not really a derivative for log 1. And therefore, we get this formula for your logarithm differentiation, with the main feature being f prime over